Well, hello and welcome, and thank you for joining me here in my shop today. I plan to do a lot of messing around and do crazy stuff here. So if you're expecting a well thought out process, no, that's not what's going to happen. Today is a day of experimenting. And what am I going to do with this radio? So because the oscillator coil is here in my hand, smashed up and not of much use, I'm going to, and the local oscillator in the radio can't operate obviously without that. Well, I'm going to see what I can do to make this radio work with an external oscillator, one of my signal generators here, and see if I can't, and just see what happens. I think a great opportunity to learn here, this is the way I love to learn stuff, is by getting out there on the thin ice of my knowledge, and I'm bound to fall through a few times here, I'm sure. So what is this all about? So this radio is quite old. If you notice, all the tubes have tube caps on them. And grid caps. I think these are all grid caps. That's a sign of the age of the radio. Plus, you might have noticed when I had the tubes out, they weren't the type that have the plastic center part. They have no center part. Instead, they have 4 or 6 pins around here. 2 of them are extra fat, and that's what keys the tube into the socket. That's an old style thing. So this is a vintage of radio. We could call this an early vintage. I guess we can call it an early vintage of super heterodyne radio. So what really stands out is that these tubes are not nearly as advanced as what's called modern tubes were or are. So these guys, they suffer problems that early tubes suffered, and they literally, they don't have, for instance, suppressor grids, and I think there's a screen grid in this tube, maybe even 2 of them. I'm not sure. I'll take a look at the schematic and we'll see. But nevertheless, these tubes have problems which their successors had designed out of them. So, for instance, I think this is a 6A7 tube here. So its successor tube, 6SA7. The S means single-ended, so this disappears and more pins show up underneath here to get rid of this cap. And the tube itself is structurally improved inside. There's the plates and different grids are done differently. They have special features, structural features inside the tube to make their behaviors different and get around the problems that exist in here. So when we're working on a radio of this age, it's these earlier epoch problems that we should be looking for. So one of them, and this is going to make things quite complicated, is that the mixer tube, this tube, is not very stable in the sense that it'll get away from you pretty easy. So if you provide it with an opportunity to oscillate, it's going to do that. And in fact, internally, it's susceptible to internally generated oscillations where through capacitance or other effects that are going on inside the tube, the signal, very simply, the amplified signal in the tube that makes its way back to its own grid and comes through again and gets amplified, and of course that'll be an oscillation. So basically the message is there are early problems or problems with these early radios which were solved by more advanced tube technology. And so again, working on this one, going to be challenging for those reasons, I imagine. I don't really know. I don't know what's going to happen here when I try to do this. I really don't. In fact, in the end, maybe I'm going to say, wow, this is a really stupid idea to even try this. So here's the coil. Here's the radio. Of course, I don't really know the operating condition of this radio. I don't know if it works. I did give it a quick test, I'm pretty sure 4 years ago when I got it, and I think the test was no, not really working all that well at all. I don't know, I can't remember. So we have 4 wires here to do something with. Yeah, this terminal that's really standing out on this radio. It's got a bunch of wires connected here. The think is the 450 volt 40 microfarad capacitor. It took a while to see that. Best thing we can do is look at the schematic, get an idea of these wires, and where it is I might want to inject the signal from one of the signal generators I have. Where would we do that? I think we have lots of options here. Also, there's supposed to be a gimmick in here. Gimmick is where you just use a piece of wire, usually insulated, and position it very carefully so it acts as a very, very small capacitor. So, where exactly that would be on here, oh boy. I don't know, but we're looking for something related to this first tube. And if I spotted it, I would feel better. Because I would be less likely to disturb it by accident. That's why I'm looking for it. I don't know. Don't see anything. Okay, let's take a look at the schematic here. We'll figure out where we would want to connect if we really gonna do this. So one thing that's good about this radio in terms of trying this out is it's a pretty simple radio. The antenna feeds right into the mixer tube. So here's the mixer tube. The cathode's right on the chassis. Then we have, I did this yesterday, didn't I? The first grid. It certainly looked to me to be tied to the output of this transformer. We have the second grid tied to a source of B+, so this is acting as a screen or actually being used as a plate, which I believe it's being used as a plate. Now the current, even if it is being used as a plate, the current flow, overall current flow, is passing right through this first grid, oscillator grid, and is being oscillated by that. So I think that's all there is to the oscillator. It's just these two leads coming back from the tube. So you know, the tube is helping make the oscillations happen. I'm going to make the oscillations happen by using a signal generator, so I don't have to make them happen. I just have to get them in on this grid. This looks really simple to me. So if we can find this grid pin for grid number 1 and simply feed the signal into there with the ground terminal of the signal generator just stuck on the chassis here. That should work. Oh, so there's the gimmick shown schematically. And it's shown associated with this lead here. Oh yeah, I remember seeing this now. So this is probably a neutralizing capacitor of just a few picofarads. And this is trying to compensate for a problem that's in this tube because of its design, or its lack of future design, as I was explaining earlier. So this small capacitance bucks away or somehow counteracts an internal capacitance that's very significant in these tubes. A problematic internal capacitance. So do I need to care about that? Probably not when I'm doing this. Probably just ignore it. This is a tiny amount of capacitance. I'm going to have the signal generator here and here. It's going through this capacitor to get to it. I don't know. We'll try to find me. Now, how many options do I have here? I don't have any options really. I can feed the signal generator in right on this line if I wanted. Right in through the antenna even, if I wanted. But I think I'm going to hook it up here for fun. So I got to figure out which grid number 1, what pin is that? Now the actual wires that are hanging free must be these 4 wires, if there's 4 in there. One is a ground, and one is the connection back to this gimmick, and also in through here. Now the tuning capacitor, so what if I'm feeding a signal here? This coil is completely missing. This wire's open, but I don't know. I don't know if that capacitor would have any effect at all. Interesting. Now, yeah, voltages. Now, well, what about the screen, the grid potential that should be on here? This is very important. The transformer is missing. So for instance, this 138 screen volts not getting on here. That's a big problem. There's no screen volts on this tube. It's worse than that. No, it's not. I was going to say there'd be no plate volts. Plate volts will be there, assuming this connection here still exists. It's this one that's lost. I would have to make a connection from this line straight through to here to energize this screen. And then, as I mentioned, this tube is quote unstable, which means if it's out of a pocket at all, it's going to do funny things. And boy, with this coil missing, the whole pocket is missing, for crying out loud. So we can operate this tube without this screen voltage. Not a good idea. So I have to jumper in the screen voltage onto this to figure out which wires it is. They are. Obviously, this is easy. It's out here where it's a little harder. Looking at the wires hanging in the radio. Okay, so if I can get the screen on there, I'm sure we're in trouble without it. Just put it straight on. Now there's another. No, there isn't. I was going to say there's another screen. Yeah, what's missing is a suppressor grid in this tube. So the suppressor grid is a grid that sits close to the plate, and its job is to scare the electrons back onto the plate if they try to sneak off. So with it not there, you can have electrons with enough energy striking the plate to not only bounce back, but to knock off more with sufficient energy to actually travel all the way back to the screen here and end up being screen current. If it's screen current, it's not going through the transformer, so it's a waste. It's a loss. So these tubes are not as efficient as ones with an extra suppressor grid here. That makes this a screen. But then I convince myself this is a screen. Could be these voltages are, and I'm sure they are, really, really particular. So 100 volts is very important that there's 100 here and 136 here, and something on the plate would be the 136. That's a little interesting in itself. You want the screen to be lower in voltage than the plate normally. But look, this screen is running at 130, whatever that is, 135, well above. Not well above. The same as the plate. So I think they really are operating this screen as a plate. Yet some of the electrons will make it through, giving total tube conduction of some amount. Wow, you can see that these voltages would become really critical in getting this whole thing to work. And I think, you know, that, I don't know if this is specific to this tube, generally true of all tubes, but maybe not so critical in most tubes to get it absolutely right. Well, this is bad news for me doing my experiment here. The 100 volts is probably there, as long as 136 is down here. Well, you know, I like doing these kinds of experiments. Most of this kind of goofy stuff I do at night. I do on my own at night because the result is 99% of the time really embarrassing. But let's give it a go. So, okay, I think I got it. We're going to try to connect the screen to something that's got some voltage on it like that. R3. We can find R3. R3 easy enough. We can find R3. R3, how does this work? R3, here we are. R3, half watt, 7,500 ohm resistor. See if we can find that. 7,500 would be, what would that be? 75. Oh, that's some weird numbers. Okay, let's take a look. 75 might indicate the earlier days of component manufacture, because I don't think 75 is not a standard number. 75. It's gonna be like a blue green. 7,500 would be blue green red. Blue green red. Oh, look at, I don't see any resistors. There's no resistors in here. Blue, green, body and dot. Body, green. What's the wrong location? Should be up in this area. Oh my gosh, there's like no resistors in here. Huh. In fact, now that I look at it, there's not much of anything in here. This guy's pretty empty. Well, where's that resistor then? It must be this one. That's a wire. Really? There's like two resistors. Come on, really? Okay. So this one is hooked up to the right tube. Pin numbering, if I've got it right, is 1, 2, 3, 4, 5, 6. That would be pin 6. Actually, it's between pin 5 and 6, this resistor. Right between 5 and 6. Right between 5 and 6, if I've got the numbering right. Okay, back on the schematic. Oh, great. So this resistor, yeah, look, it could easily be 5 and 6 right here. That could be R3. All these other resistors, I don't see them. Look at them all. Hey, how come they're all hidden in there? Oh my gosh, there's resistors everywhere. This is maybe up on top. Huh. Okay. So I'm pretty sure that's the one. Maybe we'll just measure it. And we should be able to measure it and see what we get. $7,500. $50. So it's probably a resistor inside here. Probably maybe a resistor hidden inside here. Inside here and here, I don't know. Where are they? They're MIA. That must be what's going on. They've tucked them away in here. There's another big sleeve down in here too. Very odd. That's kind of odd. I don't know why would they cover them all like that. Well, other than for the obvious protection. But that doesn't help answer this question. What's this guy doing up here? 50,000. Is there a 50K in that circuit? So we have R2 right up there. I don't think that's, I think R2. R2, 50K. The M actually means meal or 1,000. 50K. This is a half watt. A tenth of a watt. A tenth of a watt. Wow. Oh, we didn't find R3. So R3, see, it could be, it's on this wire, and it's on this wire. Maybe it's anywhere. Who knows? We have to find this connection on the 6A7, trace it back. What am I trying to do here? I'm trying to find it so I can find this point. This point is in common with this, heading for the plates. Coming off this capacitor and getting its power from here. Need to get out the voltmeter and look for this, but I had to turn the set on, and at that point I got other concerns than trying to find this. I wanted to set up before I turn the set on. So I gotta find R3. R3, yeah, like it can be anywhere. It can be anywhere between these two tubes anyway. That could be anywhere in there. It's buried from sight. R3. Okay, so let's look at finding this grid right here. 6A7. 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 Here we go. 6A7. 6A7. 6A8. It's not a 6A7. It's a 6A. Yeah, 6A7. How are mistakes made? Set the landing gear to 6A7. Yes, Captain. Glass types outline. 6A7 is identical electrically with the 6A8. 6A7S, now discontinued, has the external shield connected to the cathode. In general, its electrical characteristics are similar to those of the 6A7, but the two types are usually not directly interchangeable. Type 6A7 is used principally for renewal purposes. That didn't tell me very much. Identical to the 6A8, so 6A8 has a little more information here. 6A7, so looking at the diagram, yeah, the tube is full of grids. So we're trying to pick off the signal grid, or rather the grid that's used for the local oscillator. It's grid number 1, it's pin 5. Pin 5. Pin 5, fat 1, 2, 3, 4. Pin 5. So pin 5 has this resistor and this capacitor on it, and that's it. A resistor and a capacitor. This capacitor is cut. This was headed for the coil. So I think one of the things they're doing here and they're doing this on all radios, is trying to position all the components in a way that doesn't cause problems with cross interference or, you know, accidental inductions and capacitive connections and all kinds of stuff. So even something like this coil being put like that instead of like that, or instead of like that, these angles would be critical in the layout of the components, swinging these wires around, just doing everything exactly the same every time you build this radio, keeping this lead really, really short. This one's quite long, doesn't seem to matter so much. All these things are taken into account by the design engineer. I can only guess at them now. One thing, when I was working in the power company, we were producing plans to go out and connect new buildings and houses and things like that and extend the underground electric system, the overhead system and that in the city of Toronto. And so, a lot of thought goes into those things, of course. Lots of discussions. The designers and planners are talking about the current situation, what's it going to look like 5 years down the road. Is somebody got a building slated to be built there? We don't know about it yet. We should know about it. All this stuff goes into it. What size cable? What about the future? What about other changes in the system that have to be made? Out of all that thinking comes a drawing, like a schematic. The purpose of the drawing is to guide field crews on making the changes. The point I'm making is there's nothing in that drawing that explains any of the thinking about how things got to be the way they are. All the thinking is tossed aside or stops, and the drawing comes out. That's exactly the same with these radios. We have a schematic in your hand. It doesn't tell you anything about what thoughts were going through the heads of the designers, what things they tried and didn't work, why they have a component in a certain position, all these things that they had to work out in order to get a radio model that they could produce in a factory consistently without problems. You don't know any of it. None of it. But was it even recorded anywhere? Only in the form of any notes, letters, written stuff that might have been communicated between engineers. Most of it, airborne talk between people. So unfortunately, there's a huge amount of knowledge that is left behind in the design department. It never comes out. And this is why, by the way, if you've ever worked in one of these environments, this is why if you're in the environment that receives the instructions from the brain trust back in the head office, you tend to become pretty cynical pretty quick, because you look at it and go, well, why did they do this? Well, you don't know the answer. There probably is a good answer, but you don't know it. So it looks stupid. What? Why did they do that? That's dumb. Let's do this. Hey guys, grab that pole. We're going to stick it over there. This designer didn't know what he was talking about. Yeah, what the designer knew was that there's another building coming down the road in 2 years, already in the planning stages. And so allowances were being made in the design for that. So the point again is, an awful lot is missing when we look at these schematics. It's a very, very, very thin, it's very thin. So what are we left with? We're left with our imagination. You hear me trying to apply it all the time when I look at this. I wonder, well, why did they make this choice? And why did they make that choice? And mostly I know that probably in this radio, 1,000 or more decisions were made specifically about how to do things. And I don't know the answers to any of them. I don't even know what they are. So having cut this coil out, and realizing after a little bit of study how precarious this radio really might be to have it operate. It really needs everything in there just right, or it's never going to operate. The notion that I can hook up a independent oscillator to this thing and make it receive, wow. It just sounds totally insane. I can't even find a stupid resistor in here, let alone do that. Man alive. Oh, this is the fun though. Pin 5. Pin 5. Pin 5 is this. So off of pin 5 should be R2 going to ground. R2 in the list was 50K, and that's what I measured in the radio. So there we are. Going to ground. And I see what is probably a grounded terminal right next to it. That's what it looks like. Maybe not. Now, the others. Now there's a capacitor. Is there? I'm looking back at that. Yeah. So this capacitor, yep, goes straight to the missing coil. Maybe into this capacitor is where I should inject it. Wait a minute. The capacitor's floating free. Where's this connection? Well, this won't matter. This connection won't matter because I don't need to resonate this. There's nothing there to resonate. Feed in the capacitor. And then I'll be feeding heavily into this. Okay, you know what? You know what it is? It's try this side and try that side and see what happens. This side. So yeah, we're also looking at the bias. The bias. How did they get the bias on here? Bias. Looks like it's self-generated onto R2. That's what it looks like. R2 being 50K. Goodness knows I don't know what I'm doing. This is fantastic. Okay, let's do it. Let's do it. Okay, so I'm going to use my big honkin' signal generator here because I'm most familiar with that instrument. I'm pretty sure I can protect it. What do I need to protect it from? Accidentally hooking it up to B+. Making a stupid mistake like that. Protect it with this capacitor here. So I'm going to put him down. So the output to start off with is going to be low, and we actually don't want it modulated. I'm going to leave it modulated for now. That's kind of a weird idea, isn't it? Modulated. The signal is going to go from the chassis. And then we got here, and we got here. Only we want to use the capacitor, which I very carefully put down and then lost. Oh, here it is. Down on the floor. We'll try on the other side of this capacitor. Well, that's crazy. I got capacitor. Let's do it. Yes, crazy's never stopped me before. Does this guy have any idea what he's doing? Now what are you going to do about that screen voltage, the missing screen voltage? This doesn't really clip on there very well. Okay, we're going to skip that capacitor. Come up here. That's good and secure. Screen voltage had to find it and jumper it in. That's really the best solution here. I have another DC power supply. I could utilize it to create that voltage, but that'd be going way too far. So now I need to find a source for the B+. Settle something here. Either side of this is on ground. He says somewhat surprised. Really? This is not a ground point. Okay. Right. What am I doing again? Looking for this line here. C9. C9. Dual. 5 by 200. 9 and 10. That'd be up on top then. C9, there's C10, there's C9, there's C8. C8 is probably, oh no, it's a very small one. Okay, it looks like the only two larger electrolytic guys are C10 and C9. This one shows one side connected to the chassis. I didn't find that on the one I was poking with. What's C5? C5, 0.01. Yeah, it's just 9 and 10 that are big guys. Looking for some easy way to find this line. There's no easy way to do it. It's one of the 4 hanging wires. It's the one hanging wire that leads directly back to a coil. Oh, okay. So I need to find this. This could be hanging, or this could be connected still. This is probably what's hanging, is this little piece here. I don't know if these connections mean there's actually a connection in the radio at that point. I don't think it means that. I think it's just a schematic drawing aid. Okay, so we want to try to pick off, oh boy. Is there another screen that this goes to? Another plate. Screen. On the other side of R3. Hey, R3 is hooked up to here, to the 78 screen. The 78 screen. Okay, there's a hint. I go to 78 screen, I'll find this point. I can find the top of R3. Other side of R3 is where I want to go. Okay, there we are. 78 screen. Let's see if I can keep all this in my head. 78. Number 78. Remote cutoff pin-toed screen is 3. 78 screen is 3. Screen is 3. 78 screen is 3. 1, 2, 3. 3 has this capacitor on it, which is grounded. There's this capacitor to ground on the screen. And we're looking for a resistor. There it is. There it is. What I thought was a piece of wire is a resistor. I saw it earlier, but I thought it was a... Hey, it doesn't look to be a... Let's look at that with a close-up camera here. Okay, so that resistor's right there. That looks fine, actually. Just a little bit of dirt on it. Good. Okay. Okay, resistor looks fine. So it was the other side of that resistor is the actual supply. That's this. And there's the cut wire from it. So I have to make a connection between this wire. It would normally go through a coil, but the coil's missing, and over to the screen lug on here. The screen is on tube 78. Forgot already. didn't forget it's 3. Did not forget. Screen is 3. And 3 is where we've been fiddling this whole time. 1, 2, 3. No, here's 3. 4 has a wire. 3, yeah, you know what? 3 comes down to this terminal. Looks like it's picking up the screen voltage from this tube here. What's going on? This is not the way it's showed in the schematic. So you have a supply terminal, drop resistor, screen terminal. We have a wire going back to pin number 3 here. Screen here. Screen is energized here. It's hooked directly by wire to this screen. Is that correct? I don't quite remember it that way. Screen. No. No, it's because there's more than one screen. So this is the 100-volt screen. Screen, and then this is a pseudo plate. Other side of the resistor. Other side of the resistor should go to. Oh, you know what? I looked at the tube thing. I said screen. What? Hang on. He's babbling. He's looking at the wrong tube. 78, 60, 6A7. What are you doing, Jim? 6A7. 6A7. Which one is the fake plate on the 6A7? 6A7. I wonder if I'll ever get there today. 6A7. Fake plate, which would be grid 2, is pin 4. Pin 4. Pin 4 of the 6A7 is where I need to clip to. Okay, pin 4, 6A7. Pin 4 of the 6A7. 1, 2, 3, 4. Yeah, there it is. Open wire. Perfect. Open wire. Going to the missing coil, then the other side of the missing coil comes here. It's an awfully long clip lead for an unstable tube. Also, look at this big long antenna. So we've got the screen powered properly, sort of. We got a place to input our fake oscillator. It's almost time to fire this guy up, really. I'm going to plug in the speaker. There it goes. Yep. Careful, man. You're going to break this thing up here. Watch it. Watch it, baby. Oh, now another thing is you have to attach this guy here to here. Just see if I have a immediately handy clip. I think that'll do. Not sure. Now, what kind of signal do we want on the signal generator? So, if the radio's IF is 455, I'm not sure that it is. So older radios sometimes they have a funny IF frequency. So let's say it's 455. Then we want to be, and I want to try to tune in a real signal. Oh, that's another thing. I need an antenna on here. Tune in a real signal at 640 or 590 is the best bet. Best bet is 590. So I need the front end tuned to 590. So I'll stick it there according to the pointer. That's 590. And yeah, I'm gonna actually try to pick up a real radio signal here. Like this thing. Oh boy, why not go for the worst? Go for it. Go for everything all at once here. Maybe we'll get the outdoor antenna hooked up here. I don't think I want to hook up the ground. I'm doing this. Put this onto the antenna. Input. Got everything now. Except we haven't set the frequency over here. So 590 plus 4 is 40, 45, 1545. That didn't sound right at all. 1045, 1055. 1055 was 600. 1045. 1045. Okay, 1045 or so. Output is here, ready to connect. So radio's operating, and we don't think it's catching fire or doing something stupid. Wow, okay, this is such a long shot. It's a long shot, but let us take it. Let us take the long shot. Plug it in. Of course, I'm doing this with dim bulbs. Only this one's in, this one's out. It's maximum restriction, but it won't be much of anything for a little radio like this. In other words, this thing will come up. Okay, so that was a CB radio doing that. This thing's going to come up to full operating voltage, more or less, right away. Any problem with that? I don't think so. Any chance I'm going to damage my equipment? I'm isolating it here, and the other piece of equipment is just an antenna far away. I think we're good. I think we're good here. Setting of the switches. Okay, it sets on, and volume's up 20%. What else? What else? What else? Come on, what else am I not thinking? Oh, nothing. Nothing. Here we go. Does the light come on bright? And it comes on perfect. That's just what we wanted. See the little dial light has come on up here. Listen, everybody listen. Tune it for fun. This is what a radio sounds like with no local oscillator. Okay, funny noises there. Let's take off the antenna. Oh, okay, so something is coming through this radio somehow in some way. No local oscillator means it's kind of a coincidence if there should be anything at the IF frequency, which I think is 455. I could be wrong about that. Can we find that out quickly? Maybe I can find that out really quickly. I'm just going to take a peek here, because I did not notice it before. It's got to say it here somewhere pretty quick. 465. Okay, it's 465. It's another new number. So 455, 465. I should up the frequency here to 1055, I think. we'll fool with it anyway. Okay, I'm now going to engage the local oscillator. God help us all. So this is modulated, and it normally shouldn't be. So I'm going to turn off the modulation. Shows the signal's making it through the tube and out the speaker. That's a really good start. Now I hear the what I'm pretty sure is a fast-paced motorboating in this radio right now. But ignoring that, can we actually hear a station on this radio? Volume's cranked. So we tune the radio by tuning this signal generator. Not a thing. So I'm targeting a station coming in from the antenna, and the thing is making this roaring sound too. Cheapers. Well, I increase the strength of the local oscillator, which I think normally in a radio like this is actually very strong, really pounding. Tune. No effect. Up one more step. Tune. Sounds like a fat chance situation here. So I'm gonna use this signal generator to produce a station to pick up. And there's a fake station going here. Oh, I've made a silly mistake. Really, really silly mistake here. This is really... I've never done that before. Total mistake. Total mistake. Amazing that worked in the least. Okay. What I did was, I didn't have the output from the signal generator hooked up to the radio. Regardless of what happened there. Repeat that. We must repeat it. Because in fact what I really did was I drove an audio signal into this radio. I think that's what I really did by accident. Okay, so we're trying once again. 10, 55, up, signal strength. It's definitely this one, it's definitely hooked up. A little more. And tuning. Yeah, we can't hear anything because I'm sure that motorboating is just ruining everything here. Unstable tube. So we'll carry on now. We'll put the second signal in. What I was going to do. This way, instead of relying on some, regular radio signal, who knows how strong it is on the end of my antenna, I'll get a little more control over things with this guy. So this radio has no back on the radio. Yeah, looks okay. There's no missing antenna. Oh, what am I going to do with this loop now? It's not a, yeah, just hang it like this. Just stick it like that. Okay, let's get this guy going, not sweeping, and we want him to be around 600 or so. 600 or so. Oh, that was interesting. 600. Oop. And interesting. Okay, we'll dial this up to 600. Okay, so this is about 600 here. That'd be 1065 on the radio to pick it up. Signal output is... Oh! That's pretty interesting stuff. There's no modulation out of this. So you won't hear any modulation. So I'm going to tune the radio now. Come on, man. You can do it. Show me something fantastic. I'm sure this radio is picking up this signal. And this is 1055. It actually makes sense, but I don't believe it. So I'm going to change this and see if... Yeah, I don't believe it. So all we can hear coming out of this radio, if everything's working fairly well, beyond all this monkey business, is what comes out of the 465 IF. If we hear anything, it's got to be a 465 signal coming out of this tube. Okay, we're getting somewhere. I'm going to put this at around, we're below this change here, around 590. No reason to do 590. It doesn't make sense. Doing 590 doesn't make sense. Okay, what are we hearing this? We are. The radio's tuned to around 600. Signal generator around 600 also. Okay, let's take the whole show up to 1,000,000. I always like working around 1,000,000. It's 1,000,000 on the dial. We'll put 1,000,000 on here. I see the radio just went quiet as can be. Let's cut this back a little bit. 1,000,000. Okay, so I'm having some set this to 900. I have trouble setting this right to 1,000,000. Set this to 900 now. Signal output is strong. So I think what's happening there is as I tune through that spot, the AVC is, I don't know what's happening. That's right about 900. This is way off from helping. Let's put this up to where it would help. This would help at 1365. No effect whatsoever. $900. 1465. 1365. 1365 is what we want. Not a thing. Okay, so not a thing. I see it now. Just what's happening up here? Sounds like a lot of radio sound in my shop, just like that. That's up around 1500. Oh. Something happening at 1400. 1400 would equate to 950. Nowhere near 950. But we got 950 on here. Oh, lots of weird things going on. So in a sense, what I'm doing here a little bit crackpot. First, let's get rid of this and change this around here. Get rid of this. This is what I want to get rid of. The connection to the external antenna. I left that on there. Didn't want to do that. And now we can actually connect the signal generator direct to the antenna. Get the signal back. Ground is just out here. Let's attach it. Put a little more juice out of here. We're tuned to some crazy spot around 1500. 1500. Thing. So with it tuned to 1500, we'll tune this to around 15. Oops. Okay, let's try this one a little bit. Pretty quiet. Now we'll try to use the external oscillator to mix that signal down to 455. So we would have to be at 465, above that, 1990. That was a good year, 1990. Okay, 1990. Come on, man, make some sound at 1990. Volume's up. There we come. Sound. Okay, double check. What have I got wrong now? 1500 going in. Signal too high. see, signal too high? Could that be the case? How can that be the case? Local oscillator too low, too high? External oscillator, rather. I got my leads messed up again. No. And it could be that what I'm trying to do just doesn't work, right? It's just not going to work because of stupid things I haven't figured out yet. Really bad impedances here. Like the output impedance of my signal generator is very, very low. I do have a capacitor there. Well, let's kind of try. So there were some funny things about what this tuned like. Like in certain areas it seemed to be more sensitive than others. This radio's running on only 100 volts also. Puts it up to 115. Really, really quiet. Let's cut this signal down and cut the other signal down. No antenna except for chunks of wire in my shop. What do we hear? Nada. Okay, so we're going to feed in a signal here around 1 million. Moderate signal. Moderately strong signal. What do we hear? Nothing coming out of the IF. That's what this means. Okay. Take the input way up on this guy. Way up. Blast him. Wowie. He's getting blasted. I'm going to raise this up. So we're at 11. We're at so we're at basically 650 here. And we're at 11. What if he said 1150? He said this was 1150 and this is 650. It's 500. That's close to 455 apart. I'll do that more accurately. So I don't really know what, whether the tuning thing is accurate at all. So if this is working the way I think it's working right now, if I set the signal generator to 465 above 1 million, 1465, I tune this guy to 1 million, I'm going to hear something. Apparently not. Doing the same thing down here. If I have this thing set to 65 less than 600, which would be 35. Ooh, that's 535. That's 535. Why is it doing something there? I'm getting awfully close to the IF frequency when you get down here. Ooh, all kinds of weird stuff going on now. Quite a, it certainly sounds like feedback. This is blasting here. Let's de-blast it. What's going on there? Is that like a AVC voltage relaxing and there's a certain point where things oscillate? What was that? Oh man, okay, so yeah, I really wanted to get out there on the fringe. I am definitely on the fringe now. The radio's tuned to around 500, a little above 500. This looks like it's half of the setting. What would that matter? Meanwhile, I got the local oscillator, external oscillator going, but going low, at a low output. It's still hooked up though. So the radio's happy to make sounds here. Let's stay here. Let's just fool with this. Got down to 900. That should be close enough to 455 from here. Okay, lots of funny stuff happening there. So this sounds like a signal getting so strong something's being driven into cutoff. Not that way. Right there. You're just losing oscillation. Right there. Lots of weird things can be going on in this tube during this test. So I'm sitting right on the IF frequency right now. Or is the IF frequency actually this? Now what if I change this guy? Let's change this guy. He's a stupid frequency of 216. $430. That's stupid too. That's a stupid thing. Come on. Get it up in the... Okay, so we're up in the radio range now. 750. Vary this. Same stuff happening. They're blasting an extremely strong signal at the IF frequency into the grid of this tube, and it's just blasting the IF when it comes out. But it's not the right frequency. It's not 465. Let me back this down. .476 is what this measures out at. And it's supposed to be 465 if everything I'm thinking is right. Okay, so why won't this thing mix? Let's just try one more time. I put this up to 1,465,000. 400. Hey, we'll use this. We'll pretend that's the IF 477. So I would want to go to 1477. That should cause the radio to tune at 1,000,000. We'll set the front end to 1,000,000. There we are. And we're going to hit it with a 1,000,000 signal. We're at 700 here. Around here. 1,000,000 signals going into the antenna straight from the signal generator at a fairly significant level. I hear you, Peanut. Just hang on. But this is low. This one is low. Volume is full. Tune the radio a little bit. Nothing there. Hello? Hello, I hear you. Oh my gosh. Oh, he's pushing the door. Come on, Peanut. Come on. Yeah, come on. Push that door. You can do it. Push on that door. Give it a shove. Come on, Peanut. Peanut, I got cat food in here for you. Come on. He's just not got the steam. Come on. You're the wrong. It's at the wrong side of the door, which is what this cat does all the time. The hinges are on the other side. Come on. Peanut. He, as usual, he just wants me to come out and play with him for a while. Let's give this guy one good go. So again, we're tuned to 1,000,000. We're feeding in roughly 1,000,000. We're feeding in it at a fairly strong level. The local oscillator is what was low. The local oscillator is what was low. Something. Getting that warm and friendly smell. I didn't bring my thermal viewer in here. Get this guy a boost. Put this guy even a little closer. And that's really putting out 1,000,000. Come on, man. Show me that. Do it for me. What I hear? None of this stuff. Oh, Peanut, come on. None of these. This is not a modulated signal. Neither is this. Nada. Let's reduce this. Crazy idea. Nada. Let's increase this. Oh, this is full blast. This is not decreased. Full blast. No, this is not working one iota. Okay, I'm going to disconnect the signal generator. Leaves the antenna open. Okay, something there. So when I feed in the signal from the signal generator, oh, that's kind of interesting. It likes the noise. Okay, we're going to go like that. We're going to take this off here, put it on here. Interesting, that went quiet. Let's leave it off. Leave it off. It leaves the impedance of the antenna a little higher. Oh, we got something now. Tune. Behaving very funny. So around 900. We'll change the frequency here. Oh, seems to have an effect. Oh yeah. Hey, we're cooking now. Is it because of this? Son of a gun. I got something happening here. Son of a gun. Okay, what did we really get? We're tuned to 900. We're sending in about 1 million. We're beating the big ones right in here, 14, pretty close to 1465. Hey, this has worked. It's worked. This is working. Okay, what am I going to do with it? Let's reduce signals and see how low we can go. A little lower on the local oscillator. How about this guy? Disappeared entirely. Hear that sound? Something's going on. Either ABC activating or no, my local oscillator is not his. It's not the local oscillator. Well, it can't be what I was about to say. Wow. Okay, so this is going to be the starting point for tomorrow. I'm going to leave everything just as it is. I'm going to pick up tomorrow right from here and explore what is going on in this radio right now that it's able to do what it's doing, and whatever we can explore out of it, whatever I can wring out of this guy. Yeah, that's it. Okay. The wheels are just turning here. I got ideas just flying out of my head. So thank you very much for watching this. A little bit of nonsense here. I am out on the fringe, and goodness knows if what I think is happening here is even what is happening. I don't know yet, but something's happening. That's great. So have a great day, and we'll see what I can make of this tomorrow. It gives me a day to do a little bit of research and thinking about what I'm really trying to do here and what I'm trying to prove. Anyway, am I trying to prove something? See you on the next video.